Okay, so to the file chooser demo class, I added this text area, and here's where I instantiated. Now in this case, what I'm going to do is, because I'm going to read in a file, but we're just going to display it, and I don't want the user to be able to edit it. So I by default, the user can kind of can type in stuff. Just for these purposes, I set it to be false, meaning that we're not going to be able to mess with it, because I didn't want to screw up any of the files I was reading in. And then now I'm going to add it to the center. So let's see, what was I? Oops. Darn it. All these different things going on here. All right. Okay, so here it is. And see, now the white area is the text area. And now what it's going to do, well, let me show you what we're going to do. Now we have this open file action that was responding to the open file button as an action listener. Open file button as an action listener. And before, we simply grabbed it and put the title in. Now we're going to be reading in the file itself, assuming it's a text file. So we've been reading in text files with the scanner. And so I'm making the open file action now to be both an action listener and a runnable. So this exploits the fact that we can implement more than one interface. I want to make, and I could have had another class, but I decided to make it a part of this class. Again, that's a design decision that when you're doing your design, you can decide yourself. When you are doing something which could take a long time, such as reading in a big file, you want to put that in a separate thread. That's why we talked about threads before we even got into this, because that's an issue. If I select this huge file, it's going to take forever to read in. It's going to lock up my application if I have to wait for that. That may be something that you want. In the case of choosing the file, when I go to choose the file, this is what's called a modal dialog. In other words, I can't, I can kind of move the frame around, but it's not responsive to anything. It's not going to let me do anything until I either pick a file or I cancel. Well, and just to kind of show you what it's doing, let's pick, here's an XML file that NetBeans uses to kind of dictate its stuff. And here's what happened. It basically took the text of that and it wrote it into the text area. Again, a very simple thing with just one single invocation. All right, let's. So, but because and this was a small file, so it was very quick. But if it was a larger file or some larger, saving a file, writing a file, anything you're doing with a file system, the time it takes on that is going to be a function of how much work it has to do, and also what else is going on your computer. I mean, if you're executing a large simulation at the same time as you're doing this, then even for a moderate-sized file, it may take a long time to either read it or to write it. And so when that happens, you want to put that in a separate thread. And that's what we're doing here. So the action performed is what's going to respond to the button click, because that's what it does. But when it does that, it's going to basically invoke the runnable, the run method to do the heavy lifting. So notice that when we have chosen a file, so if the result is the approve option, then we set the chosen file, which was actually in the outer part. So now, if once we get past here, we have a file. We have a file object, and so now we can use that file object to get a file input stream, as we've done before, feed that input stream into a scanner. Now the first thing we're going to do is we're going to clear the text area, which the way we do that is we simply set its text to be the empty string. And then we're going to read it, as we've done before, we're going to read in the scanner one line at a time, and then append it to the text area. And then because we're reading it in line at a time, we have to explicitly append in the new lines, as we've done here. And then, as always, we close scanner. Whenever you have system resources, so the scanner uses this input stream, the file input stream exploits all this. It's the scanner probably closes the input stream as well, but you don't always have to, you shouldn't always rely on that. It's always best to explicitly close everything. Okay, so now how does this happen? I've added an instance variable, an executor service instance variable, because remember we saw that was the most effective way to run threads rather than kind of trying to mess with it ourselves. And so that executor service, we again use lazy instantiation for. Remember, we used lazy instantiation for the file chooser. We're going to use lazy instantiation for the executor service as well. So we're not going to create one until the first time you use it. Once we do it, we don't have to do that again. So if it's null, we get a single thread executor, because that's all we need for this. In a more extensive application, you might need more threads, or you might be kind of wild and just say, give me a cache thread pool, which will give me as many as I want. In general, it's probably not the greatest idea to have too many more threads than you have logical processors, but that's a little beyond what. And then we just sort of submit. So that's what caused this to happen. So when we decided to open our file, and let's do a little bit of where is it here? There. Okay. Okay. So this is unfortunately, yeah. There's a way to to set the fonts, but it involves some more complicated stuff that we're not going to deal with. We would deal with it in the second course if we had such a thing. So this is kind of inceptionist, because what I've done is I've opened up the source file for the program that I'm running. Okay, so in a way, this is putting together. Everything in here is putting together something that we've covered already. We've talked about action listeners and how that responds to it. We've talked about runnables and how we use executor services to submit to that. And then in another context, if we had a file object, we've been able to read that file using a scanner. Done all that before. Now there's one little problem with this, and that is, notice that we can only see a piece of the file. The whole file is here, but I can't see it unless I do something like this, and even at that I can't see the whole thing. So what is it we've come to expect from an application like this that's displaying text which may be bigger than the window that we can see it through? I expect to see little scroll, little things here where I can kind of, and even if it goes too wide, I can maybe have one at the bottom that goes like that. So, of course, that's something that we would expect, and of course, Java does provide that with something called a JScroll pane. So all we have to do with that is up here, instead of just putting the text area in, we put the text, again, and this is the kind of the Russian nested doll thing. So we're putting the text area into the content pane of the frame, but instead of that, we're going to put it into a scroll pane, and put the scroll pane into the content pane. So again, nested dolls, and here's how that looks. And what I can notice, again, overloaded constructor. I can just create an empty one. I can, there are all kinds of other fancy things I can do. Really, the easiest thing is to just put a component in, which is going to be my text area. Now, in terms of scope, there's a decision, a design decision here. I can make this scroll pane an instance variable, which would give everything access to it. In this particular case, there's no need for that because the scroll pane is just a helper thing that's going to wrap around the text area. I need to make the text area an instance variable, otherwise this inner class, an instance of this open file action would not be able to interact with it. Like here, I need the text area as an instance variable because this needs access to it. But nobody needs access to this scroll pane. So I can put that scroll pane, now I put the scroll pane in, but the scroll pane contains my text area. So that when I run it now, and I open a file, we can open it here, now just sort of automatically, I get these little bars. And that's all it takes. And they also work vertically here too. So if I squeeze this down so I can't see all the text here, then a little horizontal one opens up so I can do this here. All it took was just this one, adding this one object and stuffing my text area in it. Okay, so that's reading a file. What about writing a file? And also, what about sort of creating a file? So let's, that's where I have, let's see, it's called it text and save. Okay, so here's another JFrame. Now for this, I do want to point out something that I've done here, and that is, remember we had this inner class called a window closer that we used to prompt the user to make sure that they really wanted to exit the program. And we used that as an inner class, but it turns out that if you look carefully at that, there really wasn't a whole lot that we needed from the outer class. And the principle here is if you don't need anything from the outer class, then it's a more robust design to move it out of the class and into its own separate class. And that's what I've done. So the window closer class is now its own thing. It's pretty much identical. It's almost identical to what we had before, with one exception. And that is the one thing that we needed was we needed access to, when we showed the confirmed dialog, we wanted to make sure that that was modal and with respect to its parent. And the parent was the frame. In other words, we wanted it to appear in front of and be modal with respect to that. That's basically the way it works. Now that it's not an inner class, we don't have access to that. Remember, before we had access to it because we had access to the instance of the outer class. So does that mean that we're kind of screwed? No. It means that the confirm exit now, we simply pass it all it needs is a component. See here, where when we show confirm dialog, the first argument is the parent. And in this case, this is the source. So how do we get that source? it turns out that source comes along with these window events and the action events. So the window event in particular has an instance variable called source, and it has a getter method called getSource. Now the only problem with it is that its type is just object, because they, for whatever reason, wanted to make that as generic as possible. So the type of source is an object. So in order to use it in this context, we need to cast it to a component. And so this is the way to do a reasonably safe cast. I first check to make sure if it's an instance of component, and if you remember, component is kind of up in the class hierarchy, is several layers up from where we are. That's all we need though. So if we're a component, then I'm going to call this confirm exit method, passing it the source, and that's what's going to display the dialog. Likewise, the action event has a source instance variable. We can get that, and we say if that's an instance of component, then we will invoke, again, the same code, the same confirm exit code, which will say, do you really want to exit? And if so, we're going to exit, and if not, then we're going to do nothing. Okay, so that's that. Again, there are kind of two competing principles. The principle of minimal scope would dictate this to be an inner class, but the principle of robust components and reusability says that here we have a class which instances of which are going to can be reused now without having to. So the principle of laziness says if we extract this into its own component and then just kind of use that wherever we need it, then we don't have to keep writing it. If I left it as an inner class and I wrote a new one, I'd have to sort of do a copy and paste thing, and that's never a good idea. Okay, but what we so here what we're going to do is something similar. We have a text area. We're gonna put it in. Now I don't have a scroll pane here. I probably should put one in, but I won't for now, just because we don't need it yet. I just want to talk about this save action. Now the idea here is what we're going to do. Well, let's see what this one does. Okay, looks sort of similar. But now instead of open, our button now says save as. And notice that, I don't know if you can see it, there's a little blinking cursor in my text area, which means that I can actually type here. And I know it's kind of small. There's a way of, Java actually has a very rich and expressive way of dealing with fonts. It's a little bit beyond the scope of what we're talking about here. Okay, so, but what this is there's a text area here. And I have not set it to be not editable. In the previous one, I didn't show that, but you couldn't do this. You couldn't edit this. But that's all it takes. That's all it takes. So I have this text, and so let's say if I want to do sort of a poor person's text editor, that's all I need. But how do I save this? Okay, so now I do the save as. So what does that do? Well, I have this save button, and the save button has an instance of the save action, again another inner class. And it too implements both action listener and runnable. And like the open action, it has an executor service that's going to manage the thread, because if we're saving a lot of stuff, we still want to do that in a separate thread. But now we're going to have an instance variable called save file chooser, which is again a JFile chooser. The same class, an instance of a JFile chooser, can be used to either open or to save a file. It's usually, you can use the same object to do both. I've found in most cases it's usually a little better to have one for saving and one for opening, but again, you use them both. Lazy instantiation again. So the first time it gets called is when it's instantiated. Now we say show save dialog, which is going to bring up the save dialog, and again it's going to return a magic int, and if that magic int is the approve option, which means the user said save, then we use lazy instantiation on our executive service if necessary, and then we submit that. And then what does that do? Well, first we get the selected file from the save file chooser, because otherwise we actually don't have an instance variable for that. We don't need one because it's, well, in this case we don't. So now how did we write stuff before? Well, we had a file writer, which created a writer from the file object, and then a buffered writer, which created a buffered writer from another writer. And then we're just going to append the text from the text area. Then make sure we close all of our stuff. Okay, so very, if you, one thing that impresses me, your mileage may vary, is that there's very, very little code for a lot of functionality. I mean, we're taking a bunch of text that we've written, and we're writing a file, and it really took very, very little code to do that. But the code that we have, again, assuming that you've kind of know what all these things are, is as concise as it is. It's also, in my view, very, very clear what it's doing, and the intent of the programmer is clear when you have this code. So what does that look like? It looks like this. We save as. So okay. So where is it? Where is it? It's saving it in my home directory. That's fine. All right. Let's go make sure it actually did that. And there it is. Now, just to kind of, I do want to put a point on why we use a thread. Does anybody in your mind think, well, do we really need to use a thread for this? So let me just kind of show why that might be the case. So what I'm going to do is I'm just going to artificially I'm artificially wait for like 10 seconds. Okay. So now when I go to save the file, it's going to wait for 10 seconds just artificially to simulate, as it were, a lengthy operation for whatever reason. And what I'm going to try to do is I'm going to try to monitor the file over here. I don't know if you can see that, but what this is a preview of the file, and so if I add some more text or some different text, so what is it? The lazy. Okay, so here's some. So now this is going to wait 10 seconds before updating here. Okay, so you can actually, okay, I'm going to put it in the same place, and now I'm going to save it. Now notice that I'm still live here. The file hasn't changed yet. It's going to take about 10 seconds. This is going to change, and there it goes. Okay, so in other words, what it didn't lock up my program by doing that. If I didn't have a separate thread, if I just kind of put it on the graphics thread on the event queue, the whole thing would be locked up, and I don't want to do that. Okay, so that's. I have a little more to talk about, but I know you have other pressing matters.